Bom dia, Sao Paulo. So, my name is Ranjan. I live in San Francisco, and this is my first trip to Brazil, and I really love this country. So, thank you for hosting me here. Today, I'm going to talk about scaling a cryptocurrency exchange using data science. The exchange in particular that I work at is Coinbase. So, first, I'll do a very brief introduction to Bitcoin. So Bitcoin is the world's first peer-to-peer money, where anyone can download the Bitcoin node and send money to anyone else in the world directly from their computer without having to rely on any third party. So what Bitcoin achieved was truly revolutionary because in a completely trustless environment where I don't necessarily have to trust anyone, I can still successfully send money to another person. The two basic problems that Bitcoin solves are that you cannot double spend your money. That is, if I have one Bitcoin I send to one person, I can't send that same Bitcoin to another person. And then the second thing that it achieved is that you cannot spend someone else's money. And the way it achieves this is using strong cryptography. And the second construct that enables Bitcoin to achieve this is the blockchain. Blockchain, you can think of it as a distributed ledger, which records all the transactions that have happened in the Bitcoin network. And when I want to send money to someone, then the Bitcoin nodes, they first have to verify whether I have the private key tied to that address. That is, can I actually spend it? And then secondly, no one else would be able to spend it because you can think of blockchain as a linked list. In order for me to spend someone else's, or to spend my own money again, I will have to go back and change that blockchain. And to change that blockchain is incredibly hard because the Bitcoin nodes, they are doing what is called proof of work. Now, proof of work, you can think of it as the Bitcoin nodes, they are spending energy in order to insert transactions in the blockchain, right? And a very high-level overview of proof of work is the following. If I have a set of transactions if I'm the Bitcoin node that is called the miner, and if I'm the entity which is now going to record all these transactions, then I take these transactions, I create a hash of these transactions, I insert this hash in the blockchain. And the hash is not a simple hash. The hash has to look like a particular format. It has to have a few leading zeros in the front. And everyone else, all the other nodes are competing with me in order to create a hash which looks like that format. Once I create this hash, I insert it in the blockchain. And now the blockchain itself is, as I said, a linked list, right? And creating this hash requires a lot of power. At the moment, there's a lot of, I don't remember the latest stats, but if you were to account for all the energy which is consumed by all the Bitcoin mining nodes, then it would be in amongst one of the top 100 countries in the world, right? And in order for me to convince everyone else that my blockchain is the true source of authority, I have to go back and recreate all the nodes, right? And in order to do that, I have to spend a lot of energy, which is what makes Bitcoin, you can trust Bitcoin in a trustless environment. So Coinbase is the gateway in the US and 30 other countries in the world to buy cryptocurrencies such as Bitcoin, Ethereum, Litecoin, and Bitcoin Cash. Bitcoin is the largest blockchain, and right now, besides its use as a peer-to-peer currency, a lot of people also think of Bitcoin as the store of value. Just like gold, where people like to hedge against inflation in their currency by buying gold, a lot of folks are doing the same thing with Bitcoin. Now, there's a second cryptocurrency called Ethereum. You can think of Ethereum as the digital oil. So Ethereum allows you to create smart contracts where I can create a logic saying that in the event X happens, take money from A and give it to B, right? So people are now using smart contracts for a variety of purposes. You could have things like insurance, like in the event a catastrophe happens, then some insurance company has to pay the government. You can have things like real estate, real estate escrow type services, where in the event that you want to record that this particular real estate has changed hands from one person to the other, all of that can also happen automatically without trusting a third party. And then the third cryptocurrency, Litecoin. Litecoin was forked out of Bitcoin, and Litecoin is much faster confirmation times compared to Bitcoin. Bitcoin, it takes 10 minutes in order to achieve confirmation for a transaction. Litecoin is about 15 seconds. Now, where does Coinbase fit into this picture? So Coinbase has a variety of products which allow you to either buy cryptocurrencies. Once you have bought those cryptocurrencies, you can send it to other people via our second product called Toshi. And you can achieve a much faster and a cheaper remittance mechanism. Compared to the Western unions of the world, where depending on the corridor, you have to spend anywhere from 2 to 15% of the transaction cost in order to send money across borders, you can achieve it at much cheaper using Bitcoins or Ethereum or any other cryptocurrencies. You could also buy physical goods. So a lot of folks at Coinbase, as well as other companies nowadays, they get paid in Bitcoins. And I, for instance, get part of my salary in Bitcoins, and I have a debit card which is tied to my Coinbase account. And using this debit card, I can now spend anywhere where Visa or MasterCard is accepted. So now you can think of a future world where you do not really have to walk into a bank and verify your identity and get a bank account. You could essentially get paid in cryptocurrency, validate your identity on a cryptocurrency exchange like Coinbase, and now you have a debit card which is tied to your Coinbase account, and you can spend it anywhere you want, right? And you can also fast forward into a future where a lot of the young teenagers today, when they're playing online games or virtual games, they anyways are used to virtual currencies. They play World of Warcraft, they have virtual currencies that they're using in order to buy digital goods online. So those folks are very much used to virtual currencies. Those teenagers 10, 20 years from now are very unlikely to walk into a bank. They will just transact with a digital-only exchange like Coinbase of the future. Now, Coinbase also has a product called Coinbase Commerce, where you could spend your cryptocurrency directly in order to buy goods which are denominated in cryptocurrency, like Bitcoin. And some of the merchants that we support are Overstock, Expedia, etc. And then Coinbase is also building a product called Coinbase Custody, where in order for you to store your cryptocurrency securely, instead of having to store it yourself, you can rely on Coinbase to store it on your behalf. So we think of ourselves as the bridge between Finance 1.0 and Finance 2.0. Now, the rest of this talk, I'm going to talk about what does it take to keep Coinbase and its users secure, and where does data science come into the picture over here. So the first thing that I would like to preface is that Bitcoin is instant and not reversible, right? So when I send Bitcoins to someone, I cannot get it back from that person, right? There's no chargeback mechanism built into Bitcoin or any of the cryptocurrencies, right? And now this very feature, which attracts the good users towards Bitcoin, is also what attracts scammers towards Bitcoins, right? Because compare this to an online merchant, which is, let's say, accepting a credit card, right? When I am accepting a credit card, and someone is, let's say, giving me a stolen credit card to buy goods, that scammer who gave me a stolen credit card has bought a good and has to now sell that good in order to cash out, right? Compare that to a cryptocurrency exchange. In a cryptocurrency exchange, I can come in, I can attach a stolen credit card, I buy bitcoins, and I can send those bitcoins to a private address that only I control, right? And then I can even go and spend that bitcoin somewhere else. I can very easily convert it back into cash, right? So in a lot of ways, if I have a stash of stolen credit cards, if I'm a scammer who has bought stolen credit cards from the black market, then one of the easiest places for me to convert those stolen credit cards into something of value is a cryptocurrency exchange, because cryptocurrencies are instant and they're not reversible, right? So that makes fraud as well as the user security problems at Coinbase or any cryptocurrency exchange one of the hardest problems out there. So before I dive into the fraud and the security problems over here, the other thing I would like to preface is that majority of the users at Coinbase are coming to Coinbase for good purposes. It's a very small, minuscule fraction of users who are trying to defraud us. However, that is what makes my job interesting, and that is what I'm going to talk for the rest of this talk, right? Now, before I go into the details of user security and fraud, I just want to have a quick show of hands, and if people can tell me how many of people in the room own cryptocurrencies? Just a quick show of hands. Cool, awesome. So few. So this is our user flow, sign-up flow. So when you sign up for a Coinbase account, you first verify your email address. Then we ask you for a phone number. And then you link either your bank account or your credit card. If you're linking your bank account, then we present you with a screen like this, where we ask you to provide the username and password for for your bank account. You may choose not to link your bank account via the password flow. You can also just click this thing called Other Bank over here, and thereby you could link your bank account via just providing us with your account number and routing number, right? Now, keep that sign-up flow at the back of your mind. Now let me show you what does fraud at Coinbase look like. So a fraudster creates a synthetic identity. So a fraudster may have stolen Alice's bank account, and then they will steal someone else's identity, someone else's driver license or the social security number, and a third person, Carl's mobile phone number, right? And then they will use this information to create an account on Coinbase. Now, if they're very clever, then they will link the bank account against this fake Coinbase account such that we are not able to find out the identity behind the bank account, right? In the US, it is very hard to get the identity behind a bank account because of because it's personally identified information, and we have something called the Patriot Act, because of which you cannot necessarily get access to information behind a bank account. So now Coinbase will think that this account was created by Bob, because that's the driver license we have on file, and the scammer will buy cryptocurrency and send it off the platform, right? Now Alice will be looking at her statement, and she'll realize, oh, someone purchased cryptocurrency from my bank account. She will call up her bank and do what is called a chargeback. When she does a chargeback, then we will enter into a dispute mechanism with the bank. And in most cases, we would have to return the funds back to Alice as well. So Alice gets her dollars back. The scammer runs off with the cryptocurrency. And Coinbase is the one which is left holding the bag. Coinbase is the one which has to take that hit, right? Now, how do we detect these synthetic identities which are being created by scammers? So we use machine learning. And machine learning is being used to distinguish between a good identity and a bad identity, right? So on the, whenever we get chargebacks or reversals, then we know that that particular account was not created by that individual who, by the individual who claims to have created it, right? And then, so we get those labels of, which accounts were fraudulent, which accounts were not fraudulent. So there are two labels. And then we gather signals about the account when they are signing up, right? So everything about the account, like the phone number or the email address, we use that to look up who is this phone number registered to? What are the other social identities which are linked to this email address? What is this Facebook account? What is the LinkedIn account behind it, etc. Then we take the social security number and then we find out name, address, etc. associated with that social security number. Then we take the driver license and we extract name and address from it. We take the bank and we, in cases where we can, we identify the name and address behind the bank account, right? So as you can see, what we are really trying to do is we're really trying to identify whether the names and addresses across all these sources, they match or don't match, right? Going back over here, our goal using machine learning is to make sure that if a scammer is, let's say, stealing Alice's bank account, then the scammer has to also somehow steal Alice's social security. Coinbase, as you are interacting with Coinbase, everything you do on our site, like every time you make a purchase, every time you add a new bank account or a new credit card number, or every time you send Bitcoins out of the platform, we are learning more and more about the user. And over time, our machine learning system gets more and more accurate, right? So here, this is a chart which is showing the distribution of risk score for good users and bad. The good users are in green, and the bad users or the fraudulent users are in red. And over time, the risk score for good users is converging to a low value, whereas for bad users, it's converging to a high value. The shaded area over here shows the 75th and 25th percentile regions. And the key point to also keep in mind here is that over time, the risk score for fraudulent users is going to converge to 1 and, or a high value, and the risk score for bad users, for good users will converge towards 0. And over time, the overlap between those two areas gets less and less. That is, in the limit, the system does the right thing by giving the right treatment to the users. Now, how are we using the risk score? Way back when, in 2016, we used to ban users if they had a high risk score. But that meant that if the machine learning system was wrong, then the user had no way to prove themselves to be innocent. In other words, we did not know what were the unknown unknowns, right? Who were the good users who were fraudulently banned, right? Going forward in 2017, then, we moved towards a system where your buy limit, your risk score determines how much can you purchase on Coinbase, right? So this meant that even if you were a scammer, we would allow you to purchase a very small value, let's say $5 a week, right? And if we made a mistake that you were not really a scammer, at least you purchased that small amount. And then over time, if you observe that we were wrong and your risk score moves to a lower value, then we'll give you a higher purchase volume, right? So this allowed us to actually correct for our mistakes, right? However, so on the pro side, most users could buy in this system, but on the negative side, when the price of cryptocurrencies is going up, then users want to create accounts and they want to buy a lot at the same time. So if there was a false positive, then we were not able to give those users a high purchase power up front. And those users were, of course, very frustrated. So therefore, we've been working towards a new system in 2018 where we use where we give a high buy limit to majority of the users. However, we will not allow them to withdraw if the risk score is high. That is, we will hold on to their funds until we are sure that the account was created by the same person who has access to the bank account. So on the pro side, most users can buy a lot of crypto at once, but on the con, they do have to wait before we allow them to withdraw. So why do we even hold the funds at all? So in the US, in the ACH network, which is what is used to debit from your bank account, the time for chargebacks is very long. And you know, it's almost, it's a random process, because by the time Alice or Alices of the world are taking a look at the statement, you know, the frequency at which they take a look at the statements, they vary. I may be of the type of person who looks at my statement every day. There may be someone else who looks at the statement once a month. So based on that, whenever Alice finds that there was a fraudulent transaction, Alice is going to call up her bank and dispute the transaction. And that is why the timeline for getting a chargeback is a random process, which we found it has 95th percentile around 8 days, right? But it can occur up to 60 days, right? So therefore, even if we gave you access to your Bitcoins, in most cases, if you have a high risk score, we will not allow you to withdraw the cryptocurrency for, let's say, up to 8 days, right? But most good users will be able to withdraw them immediately. And now there's a second system we have built, which basically takes all of these things together and allows us to modify the behavior for a user over time. So a user gets a risk score when they sign up, and the risk score changes over time. And using the risk score, let's say they got a buy limit of $2,500 a week, if they were very good. If they were really bad, then they get a very low buy limit in the buy limit system, right? And now the machine learning system is going to adjust the risk score all the time, and then it may realize that we made a mistake, and therefore let's move the user from this risk score between 30 and 50 to a low risk score. So therefore the user automatically gets a high buy limit, right? Secondly, as we see that you're purchasing more and more, and we haven't seen a chargeback from this account, then we can keep bumping you up into higher and higher limits, or into lower and lower hold times, right? So this system essentially allows us to control for our losses, as well as provide a good user experience to a majority of our users. Now next I'm going to talk about what does it take in order for us to deploy our machine learning models. So first, our machine learning pipeline, a little bit about that. So in 2016, we were using a package called Worple. I don't know how many people over here know Worple. One, Giuliano, I expected. So Worple is, it allows us to create a stochastic gradient descent, which is a logistic regression model, which is what we're using in this case, to create our fraud model. Now, a very quick note about why we chose to use Worple. So Worple allows us to host the model that we have created in the daemon mode. When you're doing machine learning, then you have to worry about taking your features and their weights and storing it in a configuration file such that you can access it when you are trying to return a score for the user. A lot of times people come up with an XML-like format via which you can store the weights and the signals. However, all those schemes are prone to errors, because if you were to make any errors, then the weights that you really trained and the transforms that you used for training can completely differ from the transforms that you used for scoring, right? So we avoid all of that by just using Worple for training, as well as we just let Worple run in the daemon mode, and it loads up its configuration file, and it can actually give you the score without us having to worry about that translation layer. 2018, we are working towards our second generation machine learning pipeline. We are using AWS's SageMaker tool. And one of the things I want to highlight over here is that in a company like Coinbase, where we take security very seriously, our data scientists and data engineers don't have access to production data. So how do you go about doing machine learning in an environment like that, where you can't even access the data, right? So the workflow that we have come up with is that a machine learning engineer writes their machine learning code, they get it peer reviewed, and then we deploy the code into production by putting it into a Docker container. And then that Docker container, which has the machine learning code, is run in SageMaker. And when the model is produced, then we take that model, and then once again, we host it in SageMaker itself, in that same Docker container, and we can hit it to get the score back, right? So at no time is a machine learning engineer having access to the data. It's more like we are pushing the code where the data lives, and thereby let the code interact with that data. Now, I wanted to spend a few moments talking about when machine learning model deployments they go wrong. So this is a statement, which we saw on Reddit a long time ago, where we realize that our users, they take their buy limits very seriously. They think of their buy limits on Coinbase almost like the credit card limits. If those limits are changing, then they don't feel good, right? And this happened when we had deployed a new model. So after that, we realized that we have to take a lot of criteria into account before we deploy a new model. So what we do is we first deploy a challenger model in shadow mode, while the production model is the one which is being used to decide what kind of purchase power does the user get, or what kind of hold time the user gets. And then in the shadow mode, the challenger model we use to compare the distribution of scores between the challenger and the production models. And if the distribution of scores between the two models looks fine for good users as well as for bad users, then we know the system is working as expected. However, you will always have some false positives. Some users will end up getting a very high risk score, even if they did not deserve to, right? So in such cases, what we do is we take a look at the high net worth accounts which are getting a bad risk score, and then we give it to our analysts, who then go in and manually change their risk scores. And only then do we actually go ahead and deploy the model, right? So I wanted to bring this up just to point that machine learning, as taught in academia, is very different than when you're applying machine learning in practice, because you have to worry about all these interactions of your machine learning system with your users. Now, what are the cases where machine learning does not work to detect fraud? So, as I said, we do have the capability to deploy or to train our machine learning model very frequently, but we do not do so because we are very worried about the impact it could have on good users. But then, what about fraud? Fraud is dynamic. It's moving. Fraudsters are changing their behaviors very quickly. So in such cases, we still have to keep up with the new trends in fraud. And how do we do that? We do that via a variety of approaches, like anomaly detection. So over here, I'm showing in blue is the percentage of users who are signing up with, let's say, a bank account from Wells Fargo. If in any given week, I see that there's a big jump in accounts which signed up with Wells Fargo, then I know that maybe someone bought a stack of Wells Fargo bank accounts from the darknet market, right? Then I can give those bank accounts to my analysts, who will analyze them further and take actions on them. Sometimes the analysts, they find that there's a ring of fraud. They may find that fraudsters are using JP Morgan Chase's credit cards, and they're using Verizon phone provider to link their bank account. Then they may actually create a rule like this, where they say any account which matches this rule, either give them a high risk score or put some more friction on them, right? So we have created a rule engine for that purpose. Thirdly, we have a system called clustering, where when an account gets banned, then any account which shares strong attributes like the following also gets banned automatically, right? If two accounts share the same credit card number or same social security number, then I know they're controlled by the same individual, right? But in some cases, for some signals, I cannot necessarily say they are controlled by the same individual. If myself and another account holder share the same email address or same IP address, then it doesn't mean that we are the one and the same person, right? However, it may mean that the scammer was coming in from a particular VPN, right? So in such cases, we do not necessarily take action automatically, but what we do is, when an account gets banned, then we take a look at all similar accounts using cosine similarity score and present those similar accounts to our analysts, who take further actions on those accounts. So I'll talk about a case study here, which we call the Verizon debit card ring. So this was a case study which shows how all these systems they work together to prevent fraud. So first of all, these are photoshopped IDs. The scammer, what they did was they just changed the driver license number, and they were using stolen debit cards and Verizon phone numbers to verify accounts on Coinbase, right? We used to think that if we ask our customers to provide a phone number, then having access to a phone number is enough of a deterrent to create an account on Coinbase. Turns out we were wrong, because there are sites like receivesmsonline.net. You can go there, they will give you a temporary phone number. You use that temporary phone number, and you can then get the code, the 2FA code, straight away on the website, right? So therefore, you can verify your phone number on Coinbase, Facebook, Twitter, Instagram very cheaply, right? Secondly, we found that in some cases, when we are sending SMS 2FA tokens, then they are sometimes visible on apps or on online portals being established by telcos. In this case, one of our agents discovered that whenever he sent a text message to his dad, then the text message could be seen in his dad's online portal for the telco, right? And not only the text message, but even the SMS 2FA token was visible over there. So therefore, if I'm a scammer and I want to verify a phone number on Coinbase, I do not necessarily have to spend hundreds of dollars to get a phone number. I can just obtain someone's telco online account's username and password and verify that, right? So we fixed that problem by making sure that the 2FA service that we were using to deliver SMS 2FA tokens, that service should never deliver 2FA tokens to online portals, right? But how did we catch this ring? So we caught it because the scammers made a mistake, right? They used the same device screen resolution, 1600 by 1200, which triggered our anomaly detection system. And then when they were verifying multiple cards, credit cards on their account, one of the cards that they verified was actually already blacklisted. So you can see our event sequence over here. That card was destroyed because it was blacklisted. And when they added it, then the risk score automatically went high for that account. And therefore, we automatically lowered the buy limit on that account. So therefore, the machine learning system, which is constantly rescoring you, saved the day over here by limiting the surface area of exposure. So in a nutshell then, all those systems together, anomaly detection, machine learning, etc., they work together to prevent the scam and to limit the exposure. Now, I want to spend a few minutes talking about what are some of the clever tactics that our scammers use against us. So, as I said earlier, we rely on our customers to upload a driver license to verify their identity. But how do you trust that a person who is uploading an ID online actually is in possession of their ID, right? When you go to a bank, then you walk into the bank and you show your physical ID, and the bank teller agent can take a look at the ID, take a look at the hologram, etc., and really know that you are the same person and as on the ID, as well as know that this ID is legit, it's valid. Online, it's a lot difficult to do all of that, right? So what we do in a lot of cases is we also ask our users to show their face, not only upload the ID, but reveal their face. That allows us to then match the face in the selfie with the face on the ID, right? And shows that, yes, this person is in control of the ID, right? Sometimes we also mail a postcard to the address which was listed on the ID, such that that postcard has a 2FA code, and then the account holder has to come back and enter that 2FA code on Coinbase. That allows us to again validate that the account holder was in possession of the ID. But turns out that even selfies are not always foolproof, right? So in this case, for instance, we had asked this account holder to upload 3 fingers, write the current date, and Coinbase on a sheet of paper. And the scammer did a very clever job where they actually took this photo from Facebook and they photoshopped it very nicely, right? However, our agents were able to detect that this was photoshopped and stop this attack from happening, right? Some other selfies that we see, like people try to upload IDs from their phones, or they try to just take a printout of the of someone's face and then just upload it in front of the webcam. Or sometimes they will, because we say that the selfie has to be uploaded from a webcam. So what they do is they will download an app on their phone, which or on their laptop, which allows them to pretend as if they have a webcam, and then they'll try to upload a picture using that system, using that webcam simulator. So therefore, you see this play button in that case over there, because someone is using the webcam simulator over here. So those are the attacks which we are constantly dealing with. But sometimes we find a few funny ones as well. This was a... So in the next 10 minutes, I'm going to now talk about some of the user security challenges. Now, the first thing I want to say is that if you want someone to learn security, just gift them 1 Bitcoin, and they will very quickly learn everything about computer science involving networking, cryptography, as well as security, right? So, and the reason being that once you have crypto, then you worry about how should I store it securely? Should I trust myself, or should I leave it on an exchange, right? So, people have made some very costly mistakes. Like this individual had 7,500 Bitcoins, which would be worth $67.5 million today on the hard drive, which they lost, right? And because Bitcoin is really, being stored in a 64-bit private key. If you lose that 64-bit private key, that money is gone, right? Sometimes people store it on devices like Nano Ledger, or there's a Trezor. These are hardware wallets which allow you to store the private key securely and then tie the private key to a passcode, which is a 4 to 6 digit PIN code, as well as they tie it to a mnemonic. The mnemonic is a 24-word passphrase. If you remember that 24-word passphrase, then you will always have access to your money, right? So what I want to state over here is that in the old days, when people had lots of cash, they used to worry about, should I go store it in a bank? What if the bank gets robbed? Or should I store it underneath my mattress? But if I store it underneath my mattress, then someone can physically, steal it from my house, from underneath my mattress, right? So it is exactly the same analogy over here. Should I store my crypto on a crypto exchange? What if they get hacked? Or should I store it securely myself? But what if I forget the passcode? Or someone steals it by ransacking my house, right? So at Coinbase, we would like to say, we have taken the position that you should actually trust us than trust yourself, because Coinbase securely stores the funds by a variety of techniques. The number one being that all the Bitcoins that you're storing on Coinbase, they are pooled together, and only 2% of the crypto is accessible online. So even if there is an online hack, which by the way, hasn't happened in the history of Coinbase yet, even then, a hacker would have access to only 2% of the crypto. And our online hot wallets are insured. And the rest of the cryptocurrency, the 98% of it, is stored in cold storage. Cold storage, by that, what we mean is we take the private key and we shard it, as in we break it up into multiple chunks. And the shards are stored in geographically distributed locations in either a USB key and then compose that 24-word mnemonic, right? And therefore now I can take those 3 chunks and store it in geographically distributed locations. And as long as a quorum of those people can come together, I can unlock the funds from that wallet. The second thing we do is that we make sure that our users take the security very seriously. We encourage our users to have a strong password. and do not share your password across multiple sites. We also encourage our users to use a second factor. So the second factor apps that we recommend are TOTP apps like Google Authenticator, Microsoft Authenticator, Duo, etc. If our users still want to use SMS as the second factor, then we've still taken steps in order to make sure that SMS is not vulnerable to things like phone porting attacks. Now, I just want to ask really quickly in this room, how many, phone porting is a phenomenon in the US. I don't know yet if it's a phenomenon here. So how, in the US, it is fairly easy for you to port your phone number or to add a new SIM card. And what scammers have realized is that it is so easy that they could actually just call up the telco call center and claim that I lost my phone or I dropped my iPhone in the toilet. Can you move my phone number to this new SIM card? And the telco call center operator will just ask you a few basic questions and then give you, port the phone number to this new device. Now, once the scammer has access to your phone number on the new device, then they can receive 2FA tokens on this new device, right? If they also know your password, because you're sharing your password with other sites and that shared password was found in a breach, then the scammer now has access to both the factors, the password and the 2FA. And then they can verify themselves on Coinbase and steal the crypto from your account, right? I'm going to skip that part. Now, what we've done to prevent phone porting is that we've removed reliance on using SMS for things like account recovery, or whenever you're using SMS, we have made sure that if we are getting the 2FA token from a particular device, then we make sure that this device was indeed actually ported over by you. And I will show how we do that in one moment. The second thing we have done is that we upsell our users to use TOTP apps, right? So I'm going to skip that. So TOTP apps like Google Authenticator, whenever you pass a certain purchase volume on Coinbase, we will recommend that you install it. Secondly, we've done email campaigns where we have sent emails with a variety of subjects like this saying that install Google Authenticator. I just want to have a quick poll over here, because this is a fun exercise. How many people think when we sent these emails that the first one had the highest conversion rate? A quick show of hands. How many people think the first one had the highest conversion rate over here? Okay. So maybe I'll just show you the results. So it turns out that this one, when we said install Google Authenticator to secure your Coinbase account, had the highest conversion rate. And the reason for it being that, as opposed to all these other subject lines, the reason for that being that when you are on your mobile phone, then you only see a few words in the subject line, right? And therefore the call to action was much stronger over there. Now, the other thing that we built, which has really prevented phone porting attacks from happening on Coinbase, such that we haven't had a successful phone porting attack on Coinbase for the last 1 year, is, again, a machine learning-based system. The machine learning-based system, what it is doing is that whenever you are entering a 2FA token on Coinbase, we make a live call against a third-party system, which tells us whether the SIM number associated with this phone number has changed recently. Then we also take features like your device fingerprint, your IP address, etc., to really know whether this SMS 2FA token was entered by the same person that I saw before, right? If not, then I'm going to challenge that SMS 2FA token. I will say that I cannot accept this token. I can accept this token maybe after 2 days. And then in the meantime, I will send an email as well as an SMS blast to the owner of this account. And if the owner of the account sees that this was being done by an attacker, then they can lock their account. Likewise, whenever someone is withdrawing cryptocurrency from Coinbase, right, we have a travel rule in place which allows us to detect if this withdrawal is suspicious. It's very similar to, for instance, when you're traveling abroad and when you're trying to swipe your Visa credit card abroad, then Visa may sometimes deny that transaction. It's a very similar system. If we see that a withdrawal of cryptocurrency is happening from a brand new IP address, from a brand new device fingerprint, and someone is trying to withdraw all the cryptocurrency to a new address, then I know very likely that the user is either traveling or someone else is pretending to be that user, right? So then I will challenge that withdrawal, and I will say, no, you can't withdraw it for the next 72 hours. And again, I will do an SMS and an email blast to the user, right? However, there can be a case where, I was indeed traveling and I wanted to withdraw my cryptocurrency, and now this is a friction which will annoy me. So what we've done then is we've said, okay, if it is indeed you, then you can upload an ID and a selfie, and as long as the name on the ID matches the legal name on the account, then I will actually allow you to withdraw your cryptocurrency immediately, right? So in other words, when you're designing a machine learning system, you don't only have to worry about the accuracy of your algorithm, you also have to worry about how do you treat the false positives such that they have a good user experience, right? So before I conclude, I just wanted to highlight the team which is doing all this work, the data science and the risk team at Coinbase. We like to think of the data science team as multiple personas. We have people with all these different skills. We have data analysts, we have quants, data scientists, machine learning engineers, machine learning platform engineer, and data engineers. So I wrote a blog post about this very recently as to how did we go about building this team. Because the word data scientist is overloaded, right? Like if you say the word data scientist to one person versus the other, it means very different things to each of them. So therefore, we think of data analysts as people who are very strong at SQL, quants as those who are very strong at stats, data scientists as people who are good at SQL, stats, as well as machine learning. Machine learning engineers, they're deploying machine learning models into production, so they're very good at back-end software development as well as machine learning. Machine learning platform engineers are building machine learning training and scoring systems, so therefore they're very good at back-end systems. And data engineers are the ones who are responsible for bringing data together, and therefore they're very good at distributed systems, map reduce, etc. So this is a team behind all the work. You can reach me on via email, soups@coinbase.com, if you have more questions. I'll be hanging out for the rest of the day today. Please come ask any questions if you have, as well as feel free to email me. You can follow me on Twitter. And hopefully I have shed some light into why fraud and user security problems are very hard when you're starting a cryptocurrency exchange, and how can you use data science and machine learning in order to solve for those problems. Thank you for the opportunity to speak here today. I really enjoyed coming here to KubeCon. Thank you.